Okay, welcome to Swell Academy. Today we're talking about functions, dividing functions when some factoring is required. Now, I like to demonstrate this type of problem in kind of an unorthodox way, in a way where I'm going to show you where f of x and g of x comes from so you can understand the factoring part of it. So for instance, if I said or gave x plus 2, we'll say x minus 3. Let's say we gave this binomial here, and we want to do some FOIL first outside. And this is a good review from some of your Algebra 2 principles. Outside negative 3x, inside positive 2x, last negative 6. And we simplify, we get negative x minus 6. Yet, so the idea is this is where the f of x, if you're given f of x, x squared minus x minus 6, and you see this, I wanted you to see the FOIL before you saw the f of x so you have an idea of where this came from. And usually what they'll want to do is give your g of x where there is some x plus 2 that's involved in that as well. And maybe they put a 2x here, and then they do 2 times x, 2x, 2 times x, 2x, 2 times 2, 4, and then your g of x is now 2x plus 4. And what will happen is problems will give you that x plus 2 as a match. Now, you don't see it here when you're first given the problem, but upon factoring, it'll kind of reveal itself. So it's good to see where these came from. Now, when we do f divided by g, and we do x squared minus x minus 6, 2x plus 4, we should be looking for some factoring to take place, especially when you see this trinomial x squared minus x minus 6, and you see the binomial here 2x plus 4, where you have the 2 and the 4, and that's kind of, 2 and 4 are multiples, and so we could factor a 2 out of them. Now, just because we didn't see this part of it here, we're not seeing this FOIL, how would we go about, let's say, unfoiling this? Now, there's a couple ways to look at it. One, take your factors of your first, x and x, and take your factors of your last, which is the 6, we'll say, and come up with your factors of 6, 1 and 6, 2 and 3. Now, ultimately, we want this basically negative 1x in the middle. So what combination, one positive and one negative, would end up giving that? And we know from our FOIL that, okay, yeah, it was the x times the negative 3 and the x times the positive 2 that resulted in the negative 1x. There is another method, this box method, in which you'll put your x and x here, and then you'll test some of your factors. Let's say we test a positive 3 and a negative 2. And we basically do x times x, x squared, positive 3 times x, 3x, negative 2 times x, negative 2x, and then the positive 3 and the negative 2, we get negative 6. Now, our x squared and negative 6 are good, but when we look at our negative 2x and 3x, notice that combines to give us a positive x, and that's not what we have here. So you would make an adjustment, probably make this a negative and make this a positive, and you would see how you could come up with your factors. So this is a good way to understand kind of how to unfoil this trinomial here. So let's say we do kind of put the pieces to the puzzle together, and we come up with the x plus 2, x minus 3, which we did in the beginning, and then we factor this bottom piece we factor out a 2, and we end up with the x plus 2. See here, and actually I would even like to show this as, let's put a 2x here, making this a 2x squared and a 4x, making this a 2x squared and a 4x, and let's factor out a 2x, because I want to show you something there. Let's say we end up factoring out a 2x, from these two pieces here and here, right? We're doing 2x squared divided by 2x, and the 4x divided by 2x. That's how we end up factoring out the 2x to give us an x plus 4 divided by 2. X's cancel out, x plus 2. Now, the reason I wanted to show you that is when you come up with your domain, notice that there's two x's we have to account for. And basically, if we put this in parentheses, 2x is equal to 0, we want to look at the x plus 2 equal to 0. Now, divide by 2, x cannot equal 0. Remember, we don't want a 0 on the bottom of the denominator, or else it's undefined. Subtract 2, x is equal to negative 2. This is another result, because if I put that in here, or I put this here, the denominator is going to result in a 0. Now, the other part you want to account for is the simplification of this, meaning you have 2x plus 2's, so those will actually factor themselves out as well. And then your reduced or simplest form will actually be at x minus 3 over 2x. Now, there is another example I want to talk about with the division of functions, just a little bit more complicated. One being because I have a coefficient, we'll use plus 2, and we'll use the x minus 2. This is how we'll get our f of x. And we'll do FOIL, negative 3x squared plus 6x. Oh, we'll do plus 6x. And then plus 2x, which will give us a plus 8x. That's my inside and my outside. And the last of negative 4. The g of x, I want to look at one that would be like an x squared minus 4. Now, where would this come from? This is actually a difference of two squares. This is an algebra 2 principle here where, or even you could say where algebra 1, we're looking at this x squared, and the square root of x squared is x. So this is a square. And the square root of 4 is also 2. So what you have is a difference of two squares. Now, anytime you have a difference of two squares, this is how it's written, you know, the minus 2 and the plus 2. And if you look at it, if I FOIL this, I get x squared minus 2x plus 2x minus 4. And these will always cancel out, and you're left with the x squared minus 4. So it's important to understand basically this idea of a difference of two squares. So, some other examples would be x squared minus 9, and it has to be a difference, x squared minus 25. This is not a difference of two squares. Yes, you have two squares, yet this is a sum and not a difference, so there isn't any real way to factor that per se with doing unfoiling. Now we go to our division, and we have the negative 3x squared plus 8x minus 4, and then there's the x squared minus 4, and we end up, like we're showing you in the beginning, where that came from was the negative 3x plus 2, and the x minus 2, and here we have the x plus 2, x minus 2. So a couple of things why I want to show you this is just this idea of a negative coefficient and the fact that you could still factor, and you want to work with your box method and kind of put the pieces together. Some may not work at first. You may try a 1 and 4 and it may not work, but you have to kind of keep putting the pieces together until you get something that fits what we have here. And then we look to cancel out. Now, okay, we talk about domain. X plus 2 is equal to 0, x minus 2 is equal to 0. So we kind of come across the fact that our domain is negative 2 and 2. And then we'll look to cancel out these two pieces. And then our final reduced, simplest form division of two functions will end up being negative 3x plus 2 over x plus 2. Be mindful that if you reduce the simplest form and you just say your domain is negative 2, well, you're kind of forgetting that also putting a 2 in here, even let's say I have x squared minus 4 and I put in a 2 squared minus 4 is in fact 4 minus 4 is 0, so we can't have that here. So it is important to factor out that difference of two squares, and find your two domains. I hope this helps. Of course, if you still don't understand the factoring part of it, there are other videos to look at in which you can refresh more on your factoring.